Two tracking stations are 200 miles apart on an east-west line. They are both tracking a satellite. The western station, Station A, has the satellite on a bearing of north 29 degrees east, and the eastern station has it on a bearing of north 8.4 degrees east. How far is the satellite from Station B to the nearest tenth of a mile? And the first thing we need to do is draw a picture. So I have Station A and I have Station B. A is west of B, and they're on an east-west line, which on your notebook should be a horizontal line, and they're 200 miles apart. Okay? Now, I have a satellite, and both of these are going to be based on north. And it says Station A is north 29 degrees east, and Station B is north 8.4 degrees east. So I'm going to start with north 8.4 degrees east. Okay, and this is 8.4 degrees. And then this is 29 degrees. Alright, north 29 east. And immediately what I notice is I was given these angles. If this is north and this line is east-west, this has to be a 90-degree angle. And if this is north and this is east-west, they have to add up to 90. So this angle is the complement of 29 degrees, which is 61 degrees. So this angle is 61, and this angle from here to here is 90 plus 8.4, which is 98.4 degrees. Now, if that total angle is 98.4 degrees, we know it's not a right triangle. We know we have to use either the law of sines or the law of cosines. What type of triangle do we have? I see an angle, side, angle triangle. An angle, side, angle triangle uses the law of sines. So we have to write this out, the law of sines, and we have to label our triangle. The first thing I always like to do is label everything in terms of A, B, and C. So I'm going to call this given side, side A. Actually, no, I'm not. I'm going to call, since this is Station A, I'm going to call this angle A, and I'm going to call this side over here side A. This is Station B, angle B, and we're going to call this side B. And so that means this is going to be angle C and side C. That way everything matches what was given in the problem. Now, it asks us to find the distance. How far is the satellite from Station B? Okay, which is going to be the eastern station. So we're asked to find, what are you trying to find? And I'm trying to find side A. Okay? So given that information and given this picture, now I want to work this problem. I want to find side A. So I look at my equation, law of sines. I have A over sine A equals B over sine B equals C over sine C. And I look at what I know. What do I know? I know sine of A, right? Because I know angle A. I know the sine of B. And I know side C. I don't have enough knowns to solve this. However, if you remember from class, whenever you have an angle, side angle, triangle, the first thing you should always do is find the third angle, because you know this is 61, you know this is 98.4. How do you find the third angle? The third angle, angle C, is going to be 180 minus 98.4 minus 61. And that comes up to be 20.6 degrees. That's angle C. So now I know the sine of C. So I can use either of these equations, and I'm going to choose to use this equation because I want to find side A. So I rewrite this. A over sine, and instead of using the letter A, I'm going to plug in what I know, which is 61 degrees, equals 200 over the sine of 20.6 degrees. Okay? So this is side C, and this is angle C. And what I see here is I have one unknown, and I can solve this very simply by multiplying by sine of 61 because it's in the denominator. So I get A equals 200 times sine of 61 divided by sine of 20.6. And so I literally will type into my calculator 200 times sine of 61. I'll press enter. Then I'll divide that answer by the sine of 20.6. And when I do that, I get A equals 497.2 to the nearest tenth. And that will be in the unit of miles because the given side was in miles. Then any other side would also be in miles.